Question 1. Z equals negative 2 plus 3i is a root of that equation. Because a and b belong to the reals, another root is going to be the conjugate of negative 2 plus 3i, and the conjugate is negative 2 minus 3i. The answer is A. To confirm that, press menu, go to 2 for number, 9 for complex number tools, 1 or enter for complex conjugate, then enter negative 2 plus 3 times I, enter, and that confirms that the answer is A. Question 2. First of all, press doc, 4 for insert, 1 or enter for problem, and add a calculator. Here, all we need to do is enter the inverse normal of 0.975 for a standard normal variable with a mean of 0 and standard deviation of 1. So we can press menu and then 5 for probability, 5 for distributions, 3 for inverse normal. An inverse normal dialog box appears. Type in the area, which in this instance is 0.975. Mu is equal to 0, sigma is equal to 1, so that's all good. Press tab to highlight OK and press enter. And we get a value that's really close to 1.96, and that corresponds to option C. So the answer is C. Question 3. Press doc, 4 for insert, 1 or enter for new problem, add a calculator. Here we want to determine the cross product of vectors A and B. To find the cross product, command press menu, 7 for matrix and vector, and then scroll up to vector, arrow to the right and press 2 for cross product. First vector to enter is vector A. So what we do is press the catalog button, and then what we'll do is we will find the M by N matrix template. With that highlighted, press enter, and what we want to do is we want to create a 3 by 1 column vector. So the number of rows are 3. Press tab. Number of columns are 1. Press tab to highlight OK and press enter. And then it's a matter of entering 0, 1, 1, arrow to the right, press the comma button to separate the first vector from the second, and then repeat the process. So we go into the catalog again, and we want 3 rows, we want 1 column, and we now enter our second vector, which is 2, 0, 1. Press enter. The output is that column vector, which we can say is equal to I plus 2j minus 2k, and that corresponds to option C. So the answer is C. Question 4. Press doc, 4 for insert, 1 or enter for a new problem, enter to add a calculator. Here, the distribution of sample means has a mean of mu and a standard deviation given by sigma on root n. N is the sample size, n is equal to 5. So it's either going to be option C or D, because mu is equal to 250. And let's just quickly calculate the standard deviation. Set up a fraction using the fraction template, and then the numerator is 1.5. And the denominator is the square root of 5. Press enter, and correct 2 decimal places, it's 0.67. So that corresponds to option D. So the answer is D. Question 5. Press Dock, 4 for insert, 1 or enter for new problem. Add a calculator. Here we want to solve the equation 2x minus 4z minus 8 equals 0 for z, given that x equals 0. To do this, press Menu, 3 for algebra, 1 or enter for numerical solve. And then let's now enter the equation. So 2 times x minus 4 times z minus 8 is equal to 0, comma, we want to solve for z, and then arrow to the right and add the condition x equals 0. So we press Control equals, arrow to the left to highlight the with or the given key, press enter, and then enter x equals 0. Press enter, and the output is -2. That corresponds to the point where the plane intersects the z-axis is at 0, 0, -2, and so the answer is B. Question 6. Press Dock, 4 for insert, 1 or enter for new problem. Add a calculator. Here we want to determine the magnitude of the resultant force, and we're given 2 concurrent forces in polar form. And notice that the angle is in degrees, so the first thing we'll do is we'll change our mode to degree mode. The magnitude of a vector in TI-Nspire is accessed by using the norm command. So what we'll do is we'll press Menu, 7 for matrix and vector, 7 for norms, 1 or enter for norm. Now what we'll do is we will add these 2 vectors to obtain a resultant vector and then obtain the magnitude. So we'll use the catalog button, and what we'll do is we'll use the row vector template here, and we'll press enter, and then we'll type in 1.21 and then arrow to the right. Now press Control Catalog, and we find that this is the angle symbol. Press enter, then type in 120. Come out of there, plus catalog again, use the row vector template, and this time what we'll do is we'll enter 1.30, arrow to the right, and then press Control Catalog, the arrow, angle symbol there, press enter, enter in -160. All looks good. Press enter, and so the magnitude of the resultant force is correct 2 decimal places, 1.92 newtons. So the answer is B. Question 7. Press Dock, 4 for insert, 1 or enter for a new problem, and add a calculator. Press enter. So what we'll do here is we want to determine the number of roots of that equation that can be expressed in the form a plus bi, where a and b are both positive. You should be able to glean by looking at or imagining the unit circle and the roots of unity. The answer should be 1, which is B, so let's confirm that. So what we'll do is we will assign roots. So assign is accessed by pressing Control, symbols template. We'll assign roots to B. Press Menu, 3 for algebra, 3 for polynomial tools, 3 for complex roots, and now we'll enter W to the power of 8 minus 1, and then comma W, and press enter. And what you get there is a list of the 8 roots in Cartesian form. Now let's extract the real and imaginary parts of each. So we will press menu, 2 for number, 9 for complex number tools, 2 for real part, press var, and select roots, press enter, enter. So they're the real parts of the 8 roots. Now we'll do the same, and we'll extract the imaginary parts. So what we'll do is we'll press menu, 2 for number, 9 for complex number tools, 3 for imaginary part, press var, enter, enter. So what we need is we need the pair of values that are both positive. So once we do is we look at the second last one, where the real part is positive and the imaginary part is positive. And so by looking at the number of pairs that are positive, it's only 1, and so the answer is B. Question 8, press dock, 4 for insert, 1 or enter for new problem, add a calculator. Now the sample mean is the centre of the approximate confidence interval. So what we do is we want to solve an equation, and let's find the numerical solve command, and we'll then illustrate what the equation is. So we'll press menu, 3 for algebra, 1 or enter for numerical solve. And the centre of the confidence interval is 3.7. So we want to solve 3.7 is equal to, in the numerator here, we'll enter 3.4 plus 3.6 plus 3.9. They're 3 sample values that we're given, plus the unknown one, which is x, down into the denominator, divide by the number of values, which is 4, and then comma x, press enter. And so the remaining sample value is 3.9, and the answer is D. Question 9, press dock, 4 for insert, 1 or enter for new problem, 1 or enter to add a calculator. So here we want to determine the value of K. So menu, 3 for algebra, 1 or enter for numerical solve. Now to access the definite integral template, the shortcut is Shift+. Then we want a lower limit of 0 and an upper limit of K. And then here we use the fraction template, control divided by, can enter 1/5, arrow to the right, multiplied by e to the power of negative x divided by 5 with respect to x, and arrow to the right. And what we want to do is we want to set that equal to 0.5, and we want to solve that for k. So press comma, k, and then press enter, and correct 2 decimal places, we get 3.47. And so the value of k such the probability of random variable capital X lying between 0 and k equals 0.5, that value of k is 3.47. The answer is D. Question 10, press dock, 4 for insert, 1 or enter for new problem. This time what we'll do is we'll add a graph. Now A is 2 on t plus 1, so dvdt is 2 on t plus 1. integrate and use the initial condition, and v is equal to 2 times the natural log of t plus 1. So let's graph that, but recognizing that we can't use v and t. So on a graphs page, what we can do is we can enter 2 times the natural log, so Control E to the x there, and then x plus 1. Now, looking at the options, we can set up slightly better window than what we've got here. We'll press enter first of all, and then menu, 4 for Windows Zoom, 1 or enter for Windows settings, and we'll say something like negative 0.1, say to about 2.5, x scale of 1, and then say negative 4 to positive 4, 1, press tab, enter. Okay, so looking at the graph, looking at the alternatives, at the end point there at about a t value of 2, the velocity is just above 2, and so the answer is C. We can also add a calculator page, and we could calculate 2 times the natural log of 2 plus 1, which is 3, and then Control Enter, and see we get a value there of 2.2 roughly, which is just above 2, and so that corresponds to option C, and so the answer is C. Question 11, press Doc, 4 for insert, 1 or enter for new problem, 1 or enter for add calculator. Here we want to start, first of all, determine an approximate 95% confidence interval for mu. So we'll press menu, 6 for statistics, 6 for confidence intervals, 1 or enter for Z interval. We don't want data, we want stats. So select stats, press enter, press tab to highlight OK, and press enter. Okay, so our sigma value from the question is 0.52. Press tab. Our X bar, our sample mean, is 9.31. Press tab. N is 40. And our confidence level for part A is 0.95. Press tab to highlight OK and press enter. And reading this, the approximate 95% confidence interval for mu is 9.15 to 9.47, correct to 2 decimal places. And note there that the 95% confidence interval, or the approximate 95% confidence interval, doesn't include the population mean mu of 9.5. To do part B, we're asked to determine an approximate 99% confidence interval for mu, and again to give our answer to at least 2 decimal places. So what we can do is arrow up to highlight the input, press enter to bring it down to a new entry line, change the confidence level from 0.95 to 0.99, and then press enter. And so the approximate 99% confidence interval for mu is from 9.10 to 9.52. And note that that does include the population mean of 9.5. So to conclude in part C, the approximate 95% confidence interval does not include the claimed mean battery life of 9.5 hours. The approximate 99% confidence interval, however, does. Hence, the manager's comment is not reasonable. Question 12. Press Doc, 4 for insert, 1 or enter for new problem, 1 or enter to add a calculator. In part A, we're asked to express that system of linear equations in the form AX equals B, and you should be able to do that without any dramas. Part B asks us to use matrix algebra to express X in terms of A and B. So X is equal to the inverse of A times matrix B. Part C asks us to use that result to determine the solution of the system of equations. So what we're going to do now is we're going to, on Nspire, form the equation inverse of A times B. So to do this, what we need to do is press the catalog button, and then we want to make contact with the n by n matrix template. Press enter, and we want to create a 3 by 3 matrix. Now let's enter in the coefficients. So 1, -2, -2, -3, -1, 1, 2, 3, -5. And what we want to do is we want to raise that to the power of -1 because this is our inverse matrix. Then the multiplication key. We're then going to multiply by the column matrix -6 to 10. So we press the catalog button, press enter, and we want to create a 3 by 1 matrix. So the number of rows is 3, number of columns is 1, and now we'll enter -6, 2, 10, press enter. The output is a column matrix, -2, 3, -1, and that corresponds to the solution to the system of equations, and this solution is x equals -2, y equals 3, and z equals -1. In part D, you're asked to verify that solution using one of the given linear equations. So, for example, you could substitute x equals -2, y equals 3, and z equals -1 into the first equation, for example, which is x minus 2y minus 2z. Make that substitution and obtain an output of -6, and that verifies that the solution satisfies one of the 3 linear equations. Question 13. Press Doc, 4 for insert, 1 or enter for new problem, and add a calculator page. In part A, you're asked to determine an equation expressing z squared in terms of y squared. So using Pythagoras' theorem, z squared equals y squared plus 50 squared. In part B, you're asked to state the value of dy dt. The first sentence says that the drone travels vertically from point A at a constant speed of 8 meters per second. So dy dt is equal to 8. And then we're asked to use parts A and B to determine the rate at which Z is increasing with respect to time when the drone is 20 meters above point A. So what we need to do is we need to find dz dt, given that y equals 20, and we know that dz dt is dz dy dt. So let's form that expression and then substitute y equals 20 into it. So control divided by, and then the fraction of a half multiplied by open bracket y squared plus 50 squared, arrow to the right, raise that to the power of -1/2, and then multiply by the derivative inside. So that is open bracket 2 times y, close bracket. So that's dz dy, and now dy dt is 8, so we'll multiply by 8. Then control equals arrow to the left to get the with or given symbol, and we want to substitute y equals 20 into there. If we press enter now, we'll get an exact answer. So if we press control enter, we get correct to 2 decimal places, 2.97. And so the rate at which z is increasing with respect to time at that point is 2.97 meters per second. Question 14. Press dock, 4 for insert, 1 or enter for new problem, and add a calculator, so press enter. In part A, we can assume this because the population from which the random sample is taken is normally distributed. In part B, we're asked to determine that the probability that the mean height of this sample will be greater than 170 centimetres. So we'll press menu, 5 for probability, 5 for distributions, 2 for normal CDF. The lower bound is 170. Press tab. The upper bound, if we press the pi button and scroll across to highlight infinity, press enter, press tab again. The mean is 168.6, and press tab, and the standard deviation is 12.7 divided by the sample size, and that is 20, so we divide by the square root of 20. Press tab to highlight OK, and then press enter. And so the required probability that the mean height of this sample will be greater than 170 centimetres is 0.3110, correct to 4 decimal places. We're told that there's a 75% probability that the mean height of this sample will lie within plus or minus 8 centimetres of the population mean. We're asked to determine the probability that x bar is greater than or equal to 168.6 plus h. So we use the symmetry of the normal distribution curve here. The total area is 1. We subtract from that 0.75 and then divide all that by 2. And so therefore that required probability in part C is equal to 0.125. In part D, we are asked to use the result from part C to determine the value of H. So what we need to do now is we need to find the critical value, if you like, and equate it to 168.6 plus H. To do that, we use the inverse normal command. So we'll press menu, 5 for probability, 5 for distributions, 3 for inverse normal. Now, that required probability in part C was 0.125. So the inverse normal, the area that we need to enter here is to the left of that. So that's 0.875, or 1 minus 0.125. Press tab. The mean is 168.6. Press tab. And the standard deviation is 12.7. Divided by the square root of 20. press Tab to highlight OK and press Enter. And so we get a value which we can equate to 168.6 of 171.86, etc. So therefore, if we go up and grab that answer and then subtract from it 168.6, press Enter, we can determine that the value of H, correct to 2 decimal places, is 3.27. Question 15, press Doc, 4 for insert, 1 or enter for problem at a calculator page. In part A, we're asked to show that particle A passes through that 0.5, -3, -8. So what we need to do is let's get the numerical solve command pasted onto an entry line. So press menu, 3 for algebra, 1 or enter for numerical solve. And then what we want to do is we want to equate 4t minus 9, which is the I component of vector RA, and equate it to the x coordinate of P, which is 5. And then we solve that with respect to T. Press enter, and we get a T value of 3.5. Let's do the same now for the J component of vector RA and the Y component. So menu, 3 for algebra, 1 or enter for numerical solve. And so -2 multiplied by 5 minus T. I'll just go back there and change that to -2. So like so. And then we equate that to equal -3 and solve that for T and press enter. We should get the same T value, and we do. And given that we've got 2 T values that are both the same, in this instance 3.5, we can therefore conclude that particle P particle A passes through P. Okay. In part B, given that particle B also passes through point P, determine the value of A. So in this instance, we press menu, 3 for algebra, 1 or enter for numerical solve. And this time, what we'll do is we'll equate the I component of vector RB. So that's T squared plus 1, like so. And we'll set that equal to 5. And we will solve for T. So this is a quadratic. So there's 2 solutions. We only want the positive one. So press Control equals, there's the width or the given symbol. Paste that into the entry line, and then add the domain constraint T is greater than or equal to 0. Press enter, and so we get a T value of 2. And then what we do now is we can substitute that value of T to find the value of A. So we press menu, 3 for algebra, 1 or enter for numerical solve, and we will solve 4 minus A multiplied by 2 squared. So we're substituting in the value of T, which is 2, and then we will equate that to -8 and solve for A, comma A, press enter, and we get A equals 3. In part C, we're asked to determine the vector that represents the displacement of particle B relative to particle A during the given time of motion, and we're asked to express our answer in simplest form. So what we do is we form the vector RB minus vector RA, and that's equal to T squared minus 4T plus 10I plus 7 minus 2tj plus 12 minus 3t squared k. In part D, we're asked to use part C to determine the shortest or minimum distance between the two particles during the given time of motion. So what we'll do is we will say, well, okay, let's let vector RB minus vector RA, we'll let that be a D of t. So D, open bracket, t, and we'll assign that. So we'll press Control, symbols template to get the assign command. Press the catalog, select the M by N matrix template, and we want to create a column vector. 3 rows is good. Press Tab, 1 column, press Tab to highlight OK and press Enter. And then what we want to do is we want to enter in the components. So the I component, t squared minus 4 times t plus 10. Then the j component, 7 minus 2 times t. And the k component, 12 minus 3 times t squared, and press Enter. So that's D of t. Now the quickest way to do this is to add a graphs page. So press Control Doc and add a graphs page. And what we want to do is we want to graph the absolute value, or the in TI-Nspire language, the norm of that vector. So what we can do is we can type in norm, so NORM, and then open bracket. We can't use t here, so we'll use d of x, and then arrow to the right. And also be aware that really x is, in this instance t if you like, is greater than or equal to 0. So what we'll do is we'll put in the greater than or equal sign. So we'll type in so given, then x greater than or equal to 0, like so, and then press Enter. Now we can't see anything. That's because we need a suitable window. So if we press Menu and then go to Window Zoom, so press 4, Window Settings, 1 or Enter. So something like an X min of 1, X max of 10 is fine. Go up in ones if you like, press Tab. Something like -50 for Y min, and then press Tab, and a Y max of 200. Y scale of 50, something like that would be fine. And then press Enter. And up comes the graph, all good. So what we want to do is we want to find the coordinates of that minimum point there. So press Menu, 6 for Analyze Graph, 2 for minimum, lower bound, upper bound. And what we can see there is that the minimum occurs at t equals 2.04, correct to 2 decimal places, seconds. And the y coordinate there, if you like, is the minimum distance. And so the shortest or minimum distance correct to 2 decimal places is 6.69. Question 16. Press Doc, 4 for Insert, 1 or Enter for New Problem. This time what we'll do is we'll add a graphs page, so press 2. Now in this question, we're given 2 subsets of the complex plane. So S is a circle of radius 4 with center 1, 0. T is a half line or ray starting at but not including 0, -1. and it makes an angle of pi on 3 with the positive direction of the real axis. So our two Cartesian equations are x minus 1 all squared plus y squared equals 16, and y equals root 3x minus 1, where x is greater than 0. So what we'll do is we'll plot these two and then find the point of intersection. So press menu, 3 for graph entry edit, 2 for relation. And what we'll do now is we'll enter in the equation of the circle. So that's x minus 1 squared plus y squared equals 16. And then press enter. And our second Cartesian equation, we need to be in function graphing mode this time. So we'll press menu, 3 for graph entry edit, 1 for function. And we'll type in the square root of 3 multiplied by x minus 1, and then control equals with or given symbol, given x is greater than 0. Press enter. Okay, so what we see there is we've got a point of intersection in the first quadrant, so we need to find the coordinates of that. So what we do is press menu, 8 for geometry, 1 or enter for points and lines, 4 for intersection points, and then click on the first graph, click on the second graph, press escape, and so that's our point of intersection. And so the complex number where S and T intersect, correct 2 decimal places, is 2.67 plus 3.63i. Question 17, press doc, 4 for insert, 1 or enter for problem. Press enter. TI-Nspire can't be used in question 17. So what you do is you differentiate once to find the velocity vector and then find v squared, and what you'll find is that v squared equals r squared omega squared. Differentiate v again to find a and then find the magnitude of a. The magnitude of a is given by r omega squared. Now take that r omega squared and rewrite it as r squared omega squared on r, and you know that v squared is r squared omega squared, so therefore the magnitude of a is equal to v squared on r, and that's how you prove the result there in question 17. Question 18, press doc, 4 for insert, 1 or enter to insert problem, and 1 or enter to add a calculator. So we need to form 3 equations here. From the first diagram, we can form the equation 4 minus mu on sigma is equal to the inverse normal of 0.2. And as a decimal, that's negative 0.8416, etc. From the second diagram, we can form a second equation, and that second equation is 6 minus mu on sigma on root n is equal to the inverse normal of 0.8, which as a decimal is 0.8416, etc. And from the stem, we're given that the probability that x bar lies between 4 and 6 is approximately equal to 0.77. So from that, we can glean that the probability that x bar lies between 4 and mu is 0.77 minus 0.3, which is approximately 0.47. Multiply that by 2 to get an area of 0.94. And then what we can do is we can equate 4 minus mu on sigma on root n to equal the inverse normal of 0.03, which as a decimal is negative 0.18807. So from equations 2 and 3, they both have a denominator of sigma on root n. So if we perform the operation of equation 2 divided by equation 3, what we can do is we can eliminate that sigma on root n. We've got too many unknowns. What we need to do is we need to form two equations, or have two equations just involving mu and sigma. So when we do that, when we form equation 2 divided by equation 3, the other thing I'm going to do is I'm going to switch on Nspire. I'm not going to use mu and sigma. I'm going to use m and s. And so what we're going to do to be able to preserve continuity in the calculation, I'm going to assign m and s to be the solutions to these equations. So m, control symbols template, we'll assign that to be equal to menu, 3 for algebra, 1 or enter for numerical solve, then control divided by, and we'll type in here 6 minus m for the numerator, and for the denominator 4 minus m, and we'll set that equal to another fraction. And in this instance, I'm going to type out inv norm, like so. So what we want here is the inverse normal of 0.8. You don't need to add anything else because it's assumed from this that we're dealing with standard normal variable z. And then down in the denominator, we're going to type in inv norm, and then open bracket, and this one is 0.03, and what we want to do there is we want to solve for m, so comma m, press enter, and we get a mean of 5.38, etc., etc. Now we're going to do something similar to find sigma, which I'm going to call S, and I'm going to use the equation 1. So S, control symbols templates for the assign command, and then menu, 3 for algebra, 1 or enter for numerical solve, control divided by, and here we're going to type in 4 minus m on S is equal to the inverse normal, or inv norm, open bracket, of 0.2, and we're going to solve that equation for S, so comma S, press enter, and we get a standard deviation of 1.64, etc. Now we're asked to find the probability that random variable capital X lies between 4 and 6. So what we do now is we press menu, 5 for probability, 5 for distributions, 2 for normal CDF. Our lower bound is 4, upper bound is 6. Press tab. Our mean is M. Press tab. Our standard deviation is S. Press tab to highlight OK, and then press enter. And so that required probability, correct to 4 decimal places, is 0.4468. Question 19, press doc, 4 for insert, 1 or enter for problem. And we will start off by adding a graphs page. Now, what we're going to do in this question is we're going to let X be the birth rate for stage 1 females, and let Y be the survival rate for stage 1 females to stage 2 females. So therefore, our Leslie matrix will be a 2 by 2 matrix. Row 1, the coefficients will be x2x. Row 2, the coefficients will be y0. From the table, P0 is the column matrix 4832, and P2 is the column matrix 2521. We also know that P2 is L squared times P0. So calculate L squared given that L is x2x, y0, and we can form two equations involving x and y, which are relations, and we can therefore use relation graphing to find the point of intersection. So what we're going to do is we're going to press menu, 3 for graph entry, edit, 2 for relation. Now, when we calculate L squared times P0, we get our first element is 112x squared plus 96xy, and our second in this 2 by 1 column matrix is 112xy. So our first equation, which we can enter, is 112 multiplied by x squared plus 96 times x times y, and we'll equate that to equal 25. Press enter. And our second relation, so press tab, is 112 times x times y, and that will equal 21, and press enter. Press menu, 4 for Windows Zoom, 1 or enter for Windows settings. So let's have an x min of say 1. Press tab and an x max of 1. We can use a scale of 0.25. Press tab. Let's have a y min of -3 and a y max of 3 and a y scale, say, of 0.75. Press tab to highlight OK and then press enter. And what we're interested in is the point of intersection in this first quadrant where x and y are both positive. So all we need to do now is press menu, 8 for geometry, 1 or enter for points and lines, 4 for intersection points. Click on the first graph, click on the second graph, press escape, and our point of intersection there is 0.25, 0.75. So therefore, x is equal to 0.25 and y is equal to 0.75. What we can do now is we can store this value as x. So press Control menu, 5 for store it as x, press enter, and then Control menu, 5 for store that as y, press enter. Now let's add a calculator page. Press Control Doc and we'll add a calculator page. What we'll do now is we'll assign our Leslie matrix L. So L and then Control symbols template to get the assign command. Then press the catalog button and then access the 2 by 2 matrix template. Press enter. So here we type in x and then 2 times x and then y and then 0 and then press enter. So that's our Leslie matrix. Now we're asked to use a matrix approach to estimate the total number of females after 4 weeks. So we've got to find P4. P4 is equal to L to the power of 4 times P0. So what we'll do now is we will calculate L to the power of 4. So L to the power of 4, and then multiply that by the column matrix P0. So column matrix template in the catalogue, press enter, and P0 is 4832. Press enter, and then to estimate the total number of females, what we need to do is just find the sum of those two elements. So it's even quicker probably just to type in SUM and then open bracket, go up and grab that column matrix, press enter to bring it down to a new entry line. And so we get 26.125. So the estimated total number of females after 4 weeks is 26.